Let's now look at a few questions regarding the differentiation of trigonometric functions. The first one is this one, is question 3 on October-November 2011, paper 22. And the question is this. This diagram shows the part of the curve y equals 1/2 of 10 of 2x in this interval 0 to pi over 2. Find the coordinates of the points on this part of the curve at which the gradient is 4. So on this section of this function, you want the points for which the gradient is 4. So it would be more or less over here and here. All right? And that's basically it, 5 points. So you have to differentiate that. Let me put back on that question. It is over here. All right. I reproduced here the sketch of the graph. These are the points. So I have to differentiate it and equal it to 0. So to differentiate this function, I just leave the 1/2 over this. If I differentiate the 10, you will know from my lesson that differentiating the 10, the 10 of ax, this gives a second square of ax. Multiply by the 1/2, so basically this is going to be 1. This is the result. Equal it to 4. So I get rid of this square first, so I have now plus or minus 2. I'll turn the sec of 2x into 1 over cosine of 2x. So the cosine of 2x is either equal to minus 1/2 or 1/2, which means that 2x equals to pi over 3 or 2x equals to pi over 3 for each one of these, which means that x, that's what you want, equals pi over 3 or pi over 6. So here you have the coordinates that you wanted, and that's basically it. All right, 5 points for that. So the pi over 6 and the pi over 3, just for you to have an idea of what this means graphically. Next question. Winter 2011. No, this is the one we just did. This is spring 2015, paper 21, and it is question 3. The equation of a curve is y equals 6 sine of x minus 2 cosine of 2x. Find the equation of the tangent to the curve at the point pi over 6, 2, and then give the answer in the form y equals mx plus c, where the values of m and c are correct to 3 significant figures. Also 5 points. So you need to differentiate that. Let's go there. Okay, this is what you need to do. Let's differentiate that. This is the basically 6. The differentiation of the sine is a cosine, okay? Minus 2 times differentiating cosine of 2x. You first have to differentiate the inside, all right, which is just 2 times. If you differentiate the cosine, it's going to be minus sine. This minus and this minus will yield a plus over there. So the result is that over there. Now, when x equals pi over 6, this is going to be, just substitute the pi over 6 over here. And this is what you'll get. All right. This is going to be 6 square root of 3 over 2 plus 4 square root of 3 over 2. So that's basically just 5 square root of 3. In order for you to get the equation in terms of y equals mx plus c, you already know the m, it's 5 square root of 3. So you need to know a point of the line, and you do, which is this one, okay? So substitute it over here, so y minus that equals the gradient times x minus this. Expand, solve and simplify, and this is what you have to 3 significant figures. That's what the question asked. So the gradient is basically 8.66 and the y-intercept is minus 2.53. And that will be it for the question. Let's now go to the last exam question, which is this one. It's paper 3, November 2007. And the question is this one, question 4. The curve with equation y equals e to the power of minus x sine of x has one stationary point for which the x is comprehended in this interval, 0 and pi. Find the x coordinates of that point, that's the first sub-question, and then determine whether this point is a maximum or a minimum point. Again, we are going to the same old stuff that you already know how to do for a long time. In terms of concept, you just need to know how to differentiate this. All right? So let's go there. So this is the function. Need to differentiate it and equal it to 0. So you can think of this as a product of two smaller functions. I'm not going over the full answer as I did in my previous lesson. So I already know what to do over here. This is the product of two functions. So I have to do the differentiate the second and multiply by the first as is. So differentiate sine is the cosine, plus leave the differentiate the first. Differentiate the second and leave the first as it is. And let me start again. So differentiate the second, that is the cosine, and leave the first as is. And then differentiate the first, that's what this is, and leave the second as is. Now, this is the way it is. So now you can factorize the e to the power of minus x, and this is what you'll get, the expression that you'll get for dy by dx. Equal it to 0, and you already know what's going to happen. This is going to be impossible to solve. There's no x for which e to the power minus x equals 0. And the only one that will yield the result is this one. So basically you have now cosine of x equals sine of x. This only happens in this interval when x equals pi over 4 or 45 degrees. Okay, so you already know the value of x. Now you need to know if it is a maximum or a minimum. You could differentiate again, but it's easier since this is the only point where the original function will turn around, where the derivative is 0. So if you plug in these two values over here, you can figure out if this is a maximum or a minimum. What do I mean with this? If you plug in this value, as I did over here, and you find, as I did, that this is a positive number, means what? Means that the gradient when x equals 0 is positive. If you do the same thing for pi, as I did, and figure out that the result is a negative number, this means that the gradient is negative. So positive, negative, right in the middle, when it is 0, means that this is a maximum.